So the 2019 Leaving Cert Higher Level question 9 was a trigonometry question. The first question, well, we're told, we'll read it out here. The diagram below shows a triangular patch of ground SGH with SH is 58, GH is 30, and the angle GHS 68 degrees, this angle in here. The circle is a helicopter pad. It's in circle. It is the in circle of the triangle SGH and has a center P. So we'll come to the in circle in a minute. The first thing they ask is to find SG, this one over here. So if we just do a smaller version of this triangle, we're looking for X. We have 68, we have 30, and we have 58. You can see that we can, because we have the two sides and the angle in between, that's always an indicator that we've got to use the cosine rule. So the cosine rule, the side opposite the angle, x squared, is equal to 30 squared plus 58 squared. Just I'll write it out with the formula first. A squared is equal to b squared plus c squared minus 2bc cos a. So we're going to be able to simplify the right hand side here. Minus twice 30 by 58 by the cos of 68. So we type that into our calculator. That's going to give us 2960. 2960 point. We'll round it off here to 0.4. That's my x squared. So that side x will be equal to 54.4 meters, and that looks correct in the context of the question. If we got an answer of like 5,000, you'll see that we're wrong. The other side's being 30 and 58. So that's part one. Part two of the question asks us to find the angle HSG, which you can see is this one here. And we now have x of 54.4. So we can use the sine rule. So the sine of 68 over 54.4 is equal to the sine, we'll call it the angle A, over 30. So 30 times the sine of 68, and we should put a degree in, 30 divide, and we're going to have 54.4 sine A on the far side, so divide by your 54.4 is equal to sine A. So we can just type that straight into our calculator. The inverse of that fraction will give us the angle A, and the angle A, we type that into our calculator. Works out to be, well, the inverse is 0.85, so the angle is 30.75 degrees. Part 3, we're asked to find the area of the triangle SG. Now it's just the whole triangle, SGH or GSH. So just have a look, the whole triangle. So there's a couple of ways we can do this. Well, we have all the angles. If we want, we could get that one, and we have the sides. So the area of a triangle is half one side by the other side by the angle in between them. So the ones that, let's use the 30 to 58 and the sine of 68 degrees. So that will give me the area of the full triangle. Half 30 by 58 by the sine of 68 is going to give me 806.65. And that will be meters squared. D part 1, find the area of HSP in terms of OR. So just let's go back. Which one is HSP? HPS. So it's this one here. So the base, half the base by the perpendicular height, and this is the perpendicular height is R. So half of 58 by R, looks straightforward enough. Half the base by the perpendicular height, which was R, which is 29R. Show the area of SGH can be written as 71.2 R meters squared. So let's go back up and have a look at the triangle, the area of the whole triangle. Because all these sides are tangents, we have this triangle here, which is half 30 by R, and then the other triangle this one is half. What do we get for x? 54.4 by 4. So let's write those values down. A half 30 by r plus a half 54.4 by r plus that 29r from above is going to give me 15r plus 27.2r plus 29r, which hopefully adds up to 71.2r. 44 27, it does. 71.2r meters squared. And then find the value of r in meters correct to one decimal place. So we worked out the area, didn't we here? Yeah, we worked out the area, 806.65. 806.65 is equal to 71.2 r. So r is equal to 806.65 divided by 71.2. So it's going to be just over 10, 11 and a bit on the calculator, 11.3289. So it's correct to 1 meters. One decimal is 11.3. And that's just meters. The last part of this question gives a new diagram where we have this pole here, the vertical pole, and the angle of elevation at the top of the pole from the point P is 14. So that's this one in here. Find the height of the pole in meters to one decimal place. Now the first thing we have to do here is use the information that in circle is where we bisect the angles, and it's the point of intersection of those angle bisectors. If you imagine that one coming from there and this one coming from here. So we've worked this angle out earlier, this whole angle to be, let's just double check what it was, 30.75 degrees. So if I take this triangle out, we have this radius here, we worked it out there a minute ago to be 11.3, didn't we? We worked out our 11.3 here. So we have in this triangle, let's just draw that triangle and get some information. We have the 11.3. We have this angle here. So opposite the right angle is PS, PS, which will help us then when we're going into this bigger triangle to find ST. So we're dealing with this triangle first, and this angle in here is half of 30.75, which is 15.375. So we have O and we need H, so the sine of 15.375 is equal to 11.3 over x. So x is going to be the sine, 11.3 over the sine of 15.375. So that gives me PS, which is x, to be 42.62. So if we bring that information then back up, 42.62, we're looking for this one, we call that x as well. And we have this angle in here, so that's enough information for us. So let's just draw that triangle, the pole. This is PS, 42.62. PT actually, isn't it? PT? Yeah, it's PS we've calculated, not PT. PS, this one here, 42.62. Be careful. So we have PS, the bottom one. We're looking for the hypotenuse in this case. No, we're looking for this one here. We're not looking for the hypotenuse. So we have our angle. We have the bottom and we're looking for the side. So we have the angle. T was at the top. S. So we have 42.62. We're looking for x. And we have the angle of elevation. It was given to us in the question, 14 degrees. So we're looking at tan here with the two straight sides. So tan of 14 is equal to x over 42.62. So the height of the pole is 42.62 by the tan of 14. And 42.62 by the tan of 14 is equal to 10.62. Well, it's one decimal place, so that's all we need. 10.6 meters is the height of the pole.